It started with a faint streak in the night sky, captured by the Atlas telescopes in the Chilean desert on July 1st, 2025. At first, it seemed like just another distant wanderer, a dim point of light moving against the stars. But as orbital calculations poured in from observatories worldwide, the truth emerged like a shadow lengthening across the cosmos. This wasn't a comet from our solar system's Oort cloud. It was something far older, far stranger, an interstellar intruder, the third ever confirmed, designated 3I/ATLAS. And from the moment its hyperbolic trajectory was plotted, arcing in from beyond the heliopause at over 200,000 kilometers per hour, astronomers knew we were witnessing a visitor from another star. For years, we'd chased ghosts of interstellar space, the cigar-shaped enigma of the first, the dusty hyperactivity of the second. But 3I/ATLAS arrived silent at first, almost coy, hiding its secrets in the cold void. Ground-based telescopes strained to resolve it, estimating a small nucleus shrouded in a faint coma. Hubble peered deeper, suggesting something modest, perhaps a few kilometers across, wrapped in a diffuse halo of gas and dust. SphereX mapped its infrared glow, revealing an enormous carbon dioxide envelope stretching hundreds of thousands of kilometers, a ghostly sphere twice the width of Jupiter. Yet the core remained elusive, a pinpoint lost in the haze. Whispers spread through the astronomical community. This object was defying expectations, its chemistry skewed toward ancient, irradiated ices forged in a protoplanetary disk billions of years older than our own. Then on August 6th, 2025, the James Webb Space Telescope turned its golden mirror toward the intruder. Positioned a million miles from Earth, Webb's near-infrared spectrograph sliced through the darkness with unprecedented clarity. No press release followed immediately. No triumphant images flooded the feeds. Instead, internal data streams carried encrypted files analyzed in hushed rooms at NASA and ESA facilities. What Webb revealed wasn't just another interstellar comet. It was something vastly larger, more primordial, more unsettling than anyone had dared imagine. The nucleus, once thought compact and unremarkable, emerged in the spectral data as a behemoth, its true scale masked by a thick, irradiated crust and an asymmetric outgassing veil. Revised models, cross-referenced with Hubble's ultraviolet probes and SphereX's polarimetric maps, converged on a terrifying consensus. 3I/ATLAS's solid core spanned up to 15 kilometers across, with the full active structure, nucleus plus persistent coma, dominating a region larger than any known solar system comet in recent history. Imagine it, a frozen worldlet hurtling through our system, its surface scarred by eons of galactic cosmic rays, bombarded for potentially 7 billion years in the unforgiving interstellar medium. That relentless radiation had cooked its outer layers into a hardened mantle, trapping volatiles beneath and forcing outgassing in explosive, directional jets. Webb's spectra lit up with carbon dioxide dominance, a ratio of CO2 to water ice 7 times higher than typical comets, flanked by traces of carbon monoxide, carbonyl sulfide, and fine water ice grains. This wasn't the pristine snowball we'd expect from our neighborhood. This was a relic altered beyond recognition, its chemistry whispering of formation near a CO2 snowline in some distant ancient stellar nursery. A place where temperatures plummeted, condensing gases into a carbon-rich shell that no solar system comet could match. The awe hit first, the sheer wonder of holding a piece of another star's history in our telescopes. 3I/ATLAS wasn't just passing through, it was a time capsule, ejected perhaps from the thick disk of the Milky Way, carrying the fingerprints of planetary building blocks from before our sun ignited. Its velocity betrayed its origins. Unbound to our gravity, slingshotting past the sun at 1.36 astronomical units, close enough to awaken its slumber, but far enough to spare us direct peril. Yet as the data deepened, awe twisted into something colder. Fear. Because size matters in the cosmos, and this intruder was rewriting the rules. Early estimates had pegged the nucleus at under 5 kilometers, a respectable but familiar scale. But Webb's infrared penetration stripped away the illusions. The coma, once thought spherical and symmetric, revealed sunward enhancements, jets blasting CO2 at rates exceeding 100 kilograms per second, sculpting an elliptical shroud over 300,000 kilometers wide. Dust grains, reddish and ancient, scattered light in ways that bloated apparent brightness, fooling visible wavelength scopes. Only Webb's mid-infrared gaze could isolate the thermal signature of the core itself. A dark, low-albedo beast reflecting barely any sunlight, yet radiating internal heat from radioactive decay or lingering primordial warmth. Cross-calibrations with ground-based radar echoes and occultation timings sealed it. This was no fragile fragment. This was a colossus among comets, rivaling the megacomets of legend in effective influence, its gravitational wake perturbing dust streams across vast distances. Why does this terrify? Because interstellar objects this massive shouldn't arrive so casually. Statistical models of the galaxy's debris field predict rarities, small rocks and ice chunks flung by stellar encounters, not monolithic wanderers capable of reshaping orbital dynamics. For 3I/ATLAS to reach us intact, surviving billions of years of radiation and gravitational tugs, implies a resilience unnatural for mere ice. Its trajectory, nearly aligned with the ecliptic plane, skimming past Mars' orbit, carries odds-defying randomness, a 1 in millions alignment that optimizes visibility from Earth. As if it was meant to be seen, meant to announce its presence, deeper dives into Webb's data uncovered anomalies that chilled even seasoned planetary scientists. The outgassing wasn't uniform. It pulsed in rhythms, modulated by rotation or internal fracturing, releasing bursts that warped the coma into transient spirals. Carbonyl sulfide, rare in solar comets, hinted at sulfur chemistry forged in high radiation environments, perhaps near a long-dead supernova or the harsh glow of a metal-poor star. Water vapor, suppressed beneath the crust, emerged only in trace amounts, as if the object had evolved a protective shell against the void. Simulations ran overnight. If cosmic rays had penetrated meters deep, altering organics into complex tholins, what hidden structures lay beneath? Hollowed cavities, layered ices preserving prebiotic molecules from another world's dawn? The implications cascaded like a gravitational wave. If 3I/ATLAS is this large, how many more lurk undetected in the dark? The Oort cloud's edge blends into interstellar space, but objects of this scale could seed systems with volatiles, or devastate them on impact. Though 3I/ATLAS poses no threat, passing safely at over 200 million kilometers, its arrival forces reckoning. Our defenses against near-Earth threats assume solar-borne rocks. An interstellar giant would arrive faster, darker, harder to track. Webb's confirmation upended size paradigms, suggesting previous interstellar visitors were mere scouts. Fragments of larger bodies shattered en route. As months passed, the comet's behavior intensified. Approaching perihelion in late October 2025, it vanished behind the sun's glare, only to re-emerge brighter, its coma flaring with nickel vapor and cyanide traces, hallmarks of deep heating cracking the crust. Mars orbiters caught glimpses, MAVEN mapping ionic tails, high RISE resolving dust plumes. Even JWST, en route to Jupiter, snapped opportunistic frames, revealing multiple tail structures fanning into the void. The object grew greener in filtered images, diatomic carbon glowing in the thinning atmosphere, a spectral fingerprint of exotic organics. Yet beneath the spectacle lingered unease. Webb's final extended observations, before the comet faded toward Jupiter's orbit, captured something profound, a persistent asymmetry in the thermal map. Not random rotation, but directed venting, as if relieving pressure from within. Models suggested internal differentiation, dense core, porous mantle, capable of surviving not just this pass, but countless stellar encounters. A survivor, an ancient traveler, perhaps the oldest solid body we've ever probed, predating our solar system by billions of years. In the quiet of deep space networks, transmissions carried the revised truth. 3I/ATLAS isn't just bigger. It's a harbinger. Its scale challenges formation theories. How does a 15-kilometer ice world eject without disintegrating? Its chemistry probes alien disks, revealing CO2-rich zones where water snow lines shift under different stellar winds. And its presence here now, in an era when Webb can dissect it atom by atom, feels almost orchestrated, a cosmic revelation unveiled in infrared glory. We stare into the abyss of its spectra, and it stares back, a frozen giant, scarred and immense, carrying secrets from the galaxy's dawn. Fear mingles with wonder. What if this is only the beginning? What if larger shadows follow, drawn by the same invisible currents? James Webb didn't just measure a comet. It unveiled a titan from the stars, confirming that the universe's depths hold wonders and threats beyond our wildest calculations. As 3I/ATLAS recedes into the outer dark, bound forever outward, it leaves us changed, humbled, watchful, in awe of the vast, indifferent cosmos that sent it our way. The data is clear, the truth is immense, and in the silence of space, something ancient has passed closer than we ever thought possible.